Hi, everyone. Okay, let's start. My name is Gordon, and I come from the Alibaba Damo academic. I'm not the author of this presentation. It belongs to my colleague. He is also the chair of the Android SIG. And unfortunately, he cannot come here, so I will speak on behalf of him. Today, I will share our experience, some experience about our productization of Android on RISC-V. And during the recent years, we have paid a lot of effort on the RISC-V Android productization. We have reached some milestones. We began our work at September 2022, and we started our AOSP mainline upstream and started our porting the RISC-V. And last year, August, we finished our prototype product on our evaluation board, development board. And this year, we let the products to the market, and we finished our standalone product. And next, we hope we not stop at the standalone product. We hope we can really produce the Android certified products such as phone, pad, and you can freely install the Android applications just like the ARM-based stuff. Yeah. The productization Android, we made a lot of challenges. We summary to them in three parts. The first is the building product application, and the second is the performance optimization. The last one is the product maintenance. For the building product application, this is your first, when you get in the Android development, you should make it. That means you need to build your image out. Yeah. And an AOSP build system that you will meet several problems, such as the application's code is incompatible with the current tool. And for the RISC-V, you need to update the code to utilize the latest API level. And the left side, you would see in AOSP build systems, there are two parts, some related to the Android Runtime for the Kotlin, for the bytecode, for the APK. That's all Android native stuff. And another part is about native code. That means Android not only the Java-based ecosystem, it needs a lot of stuff from the native libraries, and you need to mapping your Gradle configuration system version to the Android Gradle protocol version and NDK version. Actually, that's very massive and mixed in Android systems. They have a lot of mapping. Yeah, if that means different version cannot compare with others, so you need to compose them. That will take you a lot of effort. And you will find something such as you need a Rust, but you would find that the Rust tool in your current AOSP, it cannot support RISC-V. You need to upgrade your version of the Rust. But when you upgrade your Rust toolchain, you will meet some version mapping problems. So that will take you time to deal with. And some third-party closed source libraries, ARM-based systems, you need to put them to the RISC-V and put it into the open source alternatives. So when you finish that, and you will successful building your image out, and you can have the first step. And then you will get in another stuff for the productization, for the performance analysis. In the Android, for the AOSP, we have very famous tool. And the first one is the Perfecto. Yeah, Perfecto is a graphic tool, and it could identify the usage and the dependency of the thread through the timeline chart and the dependency relationship. You can find out what's happening in your internal ecosystem. And for us, we use Perfecto to find a lot of high resource consumption by the AI algorithm and some redundant application logic. And we could find what's the critical thread is not sufficient. And some we can find what happening and what thread blocking the system performance. And the second is a simple perf. Simple perf is just like Linux perf. It could provide you the state record, and you can use it to measurement the hot port code instructions flow, and you can get the cycles, instructions, counters, and the catch event and the TLB miss. And with this information, you can know what's happening in your hot port, in your code, and you can give the assembly level optimization and using some microarchitecture pipeline to organize your instruction flow. Yeah, that's two famous and popular used two tools. With these tools, you can begin your runtime optimization. And this slide is about Android COM optimization. The upper half of this page is about the Android optimization, and this is about Art runtime. We focus on the JIT and the interpret optimization with our Xuantie specific instructions, and we use the Kevlin mark to measure it, and you will find that before our optimization is the blue one, and the purple one is the after optimization, and the gray one is comparison platform. And you will find after optimization, that's the effect is significantly improved. Some cases such as string not reach the comparison platform, but that could reach our productization requirement. And in the down half of this page, it's about native native library optimizations. The native libraries optimizations include the libc and Skier and a lot of native code libraries, and we use the Xuantie extension, use the vector extension, and use some built-in optimization this skill. And we also pay a lot of effort on the two-chain LLVM optimization. And after this optimization, we can gain the native code performance improved, such as the Comark, Drystone, Mbench, and Bionic libraries, and some libc. Here is the runtime optimization. And the runtime optimization is about the Android COM optimization. Actually, when you productization, you need some drivers. You not only do with the CPU, you also need to do a lot of IPs, a lot of hardwares in the SoCs. Here is an example. It's a case and how we do with the camera, bring the camera image to the virtual algorithms. Firstly, you will allocate the buffer from the application, and then you will pass this buffer to the camera service, and this is the Android HAL layer, and then pass it to the camera driver, and then pass it to the ISP and to the post process, and then the result back to the application, and you will transfer the DMA buffer to the surface, and let the surface code directly show on your screen, or pass it to our Xuantie VPB pipeline to deal with the virtual algorithm. And all of this stuff is no related any CPU memory copy, and we make it full page zero copy. That's a productization requirements, and you can get the best performance on your SoC. So conclude with this full page zero copy optimization. We support a complete zero copy data transfer from the camera to the virtual algorithms, and the link performance is is improved by the 172% in the application scenarios. And also, not only for the camera, but also for the video encoding and decoding process, also support zero copy. We use this method on the video codec. AI, yeah, maybe AI not so related to the Android infrastructure, but you need AI in your productization. So we put the AI, the framework into our Android ecosystem, and to mapping the original model format. And we have two infrastructure made up by us. One is called heterogeneous HHB, and one is about the structure of the heterogeneous library, SHL. And these two part is for different usage. The HHB could directly take the model format and then mapping it to the CPU and NPU. And the SHL is low level, and it's connected to the ONX runtime and to help the ONX runtime running. And also we can provide some SHL API to coding with some very specific usage. Yeah, and the right side is a performance comparison with the CPU models for the inference. And you would see, yeah, we use the RISC-net 50 and the mobile net. And you would find our optimization, only could reach the comparison scale. But that does not reach the requirement of the productization. We use another very important method, that's quantization. Quantization could help you to improve the performance a lot. That means you reduce your data type to half, and you will gain the double performance. The green one color is show how we got the result, and we can make this reach the requirement of the productization. Yeah, by integrating the SHL and the processing with the efficiency has improved over the 81%. And we conclude that with the SHL contain the code generation optimization and graph optimization, and we also maximum the CPU performance usage. And the last one is I have mentioned the quantization, and the quantization it help us to make the productization, yeah. After this optimization, the last one is the product maintenance. Yeah, product maintenance is massive. It's a lot of stuff you need to deal with, and such as you need to involve a lot of people to help you with the aging test, and you need to give some the user configuration to different usage. And for the manufacturing, you need to give out the factory image flashing too, and you need during the life cycle, you need to give the OTA upgrading service. So product maintenance is very not too much to mention, but it's very important. And then we have done three type of the standalone products. The first one is very important, is our financial payment terminal. And the second is sync client. And the third one is some people use our chip to build the elastic metal server. Yeah. And financial payment terminal, and we have put that in our convenience stores. And when you get in the convenience stores, that's an amazing experience. You will see, wow, that's the RISC-V based Android payment terminal, and replace with the ARM-based one. Yeah, that was I mentioned the comparison platform. And with the payment time optimization, we use three optimization I have mentioned that we reduced from the 7 seconds to the 3 seconds. And for the security, we have supported the trusted boot, and we have the supported the trusted execution environment, and this have passed GP certification. And And we also have finished the complex application dependencies that involve 7 system applications and more than 300 package dependencies that involve a lot of guys, a lot of colleagues, my colleagues and engineers help this finished. And the product dimensions is very limited. And we also deal with some passive cooling and some DVFS, some automatic frequency and voltage scaling method to about thermal controlling. That's our product first Android standalone product. And second one is thin client. We have put that in our booth, and you can go our booth, have a look on our thin client, and it could run Android. And we have give a very smooth display experience with the 30 FPS and high resolution DPI. And this thin client support 2 HDMI port. That means you have 2 screens, and use these 2 screens, you can do some office job. That's very have a good experience, and you can run the Windows system remotely while our cloud desktop. Yeah, that's our thin client can show you. And to improve the thin client experience, and we also done some, we support YUV for 444, yeah, and it could improve the text display, this format, color format, yeah. And in the end, and welcome all of you join the RISC-V Android software improvement, and welcome you join the RISC-V Android SIG meeting. And for the productization, summary what we have done in this picture. And the blue one is in the application, you need to do a lot of the criminal and the Google Pinyin and a lot of applications integrated with your product. And the low level, you need to deal with the Android drivers, Linux kernel drivers, and about the TEOS and U-boot. And for the manufacturer, you need to provide OTA, needed flashing. Yeah, that's out of the AOSP could provide. So productization need a lot of more effort. Yeah, the future, we hope we can support more popular applications. We hope we could support Android certified devices such as wearables, TVs, phones, and that's all. And thanks for listening. Yeah.
Yeah, I was wondering, when do you think the first mobile phone that uses RISC-V is going to be ready? And in which continent do you think that is going to be the first one to be released? I mean, Asia, America, or Europe?
No schedule. Yeah, you know, in this presentation, I have shown you that the standalone product is ready. That means if you build with the AOSP, that's okay. But the AOSP not equal to the Android. Android belongs to Google, and you need to pass the Google certificate. And now, with the RISC-V international help, in the SIG, we are talking about how to define the ABI, define a lot of standard about Android products. It is, and we hope it could come soon, but maybe it take 2 years or 3 years. I don't know. So now, if you want to build some standalone products, we have proved that's good success. You can make money with that on business. Yeah, that's it.